Hello guys, welcome back to our channel. By the way, I'm Judge Matthew De Leon and I will be explaining the components list and their purpose. We have 7 components list, such as the Arduino Uno, 8-segment LED, IR receiver diode, jumper cable resistor 220R, breadboard, IR remote control. First, we have the Arduino Uno. It is a microcontroller development board based on the ATmega328P, featuring digital I/O pins, analog inputs, and USB interface for programming. Its purpose is to read the IR remote signals and light up the correct segments of the 8-segment LED to display the numbers or update them based on increment-decrement commands. Second one is the 8-segment LED. It is an electronic display made of 8 individual LEDs arranged to form numbers from 0 to 9, including the decimal point if used. Each segment can be individually controlled by the Arduino. Its purpose is to display the number selected on the IR remote, allowing visual feedback for each button press. The third one is the IR receiver diode. It is a sensor that detects 38 modulated IR signals from a remote control and outputs a digital code that can be read by the Arduino. Its purpose is to receive the commands sent by the remote control so the Arduino can determine which number or command was pressed. The fourth one was the jumper cable It is a flexible wire with metal pins at both ends used for quick solderless connection between the Arduino, breadboard, and components. Its purpose is to connect the Arduino's digital pins to the segment of the display and the IR receiver, allowing power, ground, and signal to flow. For the fifth place, we have the resistor 220R. It is a current limiting resistor that prevents excessive current from flowing through the LED segments. Its purpose is to protect each segment of the 8-segment LED display from burning out and ensures consistent brightness. For the sixth place, we have the IR remote control. It is a handheld device with multiple buttons that emits infrared IR signals when pressed. Each button sends a unique code. Its purpose is to allow wireless control of the LED matrix by sending IR codes to the receiver, letting you change numbers or perform actions remotely. For the last place, which is the seventh, is the breadboard. It is a reusable prototyping board with internal conductive strips for easy wiring. Its purpose is to serve as the main platform to mount the IR receiver and resistors and to connect to the 8-segment LED display to the Arduino without soldering. Thank you for watching our videos and see you later.
Good day everyone, welcome back to our channel, and today we will be making the last project for our Arduino LED project. So our project we'll be making today is project 15, which is the infrared controlled LED matrix. So let's get started.
All right, welcome. All right, so this is Act 15. Welcome. I'm Zion Zelas Bardos, and this is VoltWire. So this is another program. I'll be trying to explain at the very least. We all we have here 4 pins. All right, four. We also have the IR setup so it can actually work properly within the code. So we also have the library. I know I did talk about that in the last video, but I will be talking about this again just so I can show you. If you search up library manager on the left here, it looks like a bunch of books, and search up IR remote, you can get this, which is by Sheriff, Zeto, and Arminjo. Uh, just take note that the the version that you should be installing is less than 2.7 or equal to 2.7, which is this. So anything lower and or equal is good enough for the program. So anyway, moving on. So we have here a state which tracks the current number, which is whatever hex code from here is outputted from the remote. So we have here an array of 12 units or items. So we have here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the decrement and increment. The decrement and increment is just there so it can go up and down without actually having to press the other buttons, which skips the other buttons. So this is the segment patterns for what do you call this? The what is it? Was an 8 segment display. So an 8 segment display has you guessed it, 8 segments. It shows that each segment has its own code, which turns it on. So this turns on the middle one, which is at the middle. Blah blah blah, yada yada yada. Excuse me. Cut that out, please. Moving on. I will now be going to the functions. Alright, so we have two functions. First of all is void number show, which is just a for loop for the pins or the segment, most likely. And if it displays what number is on the segment, and it just returns. That's it. It also has a feedback, which is LED in high or low. It's just there so that you know that you got the code if it doesn't display. So it's just there for debugging purposes. So let's continue. Let's continue. We have the setup. Sorry. Let's continue. We have the setup, which is first of all the serial monitor, which in turn for debugging purposes only. And then we have to look at the for loop. Again, this just defaults to the segment. It just makes it so that whenever you start up, it's outputted to a 0 or an 8, mostly a 0. Anyway, our next pin is for the LED, just for like again debugging purposes. Don't actually have to use it, but we have it. Now we actually have the entire code here. It's gonna be a doozy trying to explain, so I have a script here. Excuse me. This uses an IR remote to control an 8-segment display and feedback LED. Each button on the remote sends a unique code. The IR remote sends a hex code so that the IR receiver picks it up and decodes it. If the IR receiver picks up a code that is within the code of our program, which is these, and if it's accepted, it will output this specific code. Excuse me. If I press a number like 5, the system matches that code and to the digit, and the seg the display. If I press 5, the display will show up 5, and uh, the LED will blink slightly for a brief amount of time. Also, the segment pins are wired from pin 2 to 9. Each digit has a predefined pattern stored in the matrix. So there's also a feedback LED on pin 11 that blinks briefly whenever a valid command is received, just to confirm the action. Aside from direct number input, I can also increment or decrement the current number using two special buttons, which is from the hex code 0xFD20DF and 0xFD609F, which is for the decrement and increment. We also have here the increment decrement command. If the value is equal to the codes and equal to the current number is greater than 0, the current number is what? It's decremented. It's minus. So if the value is found within one of the codes within the array, which is specifically 11, and the current number is less than 9, it will increment it. It will increase it. So it's just there just to make sure that the program doesn't crash or make any errors during runtime. It's important that you have a limit for these. Anyway, we also this is the last one, which is the serial print, which outputs whatever you press on the IR remote. It outputs anything received, and then it has a slight delay before receiving another acceptable hex code. So that's about it. Thank you for listening. I hope you enjoyed, and that's about it. Thank you.